In this video, we will discuss about glycosylation in TGF-beta receptors and its role in TGF-beta signaling transduction. So, in the previous video, we have understood that this TGF-beta interact with the two receptors, and the phosphorylations of those receptors will trigger intracellular signaling pathways. And those two receptors are TGF-beta receptor 1 and TGF-beta receptor 2. So, one of the important characteristics is that they both need to be expressed on the cell surface, and the important glycosylations that plays a role towards the cell surface expressions is the core-fucosylations. So core-fucosylation of both of these receptors is important for them to express on the cell surface. And afterwards, in the case of the TGF beta receptor 2, there is a beta 1,6 branching of the glycans, and this branching reinforced this TGF beta signalings by preventing the endocytosis of the TGF beta receptors, and thereby interacting with the TGF beta receptors for a longer duration of time at the cell surface. And the role of TGF beta receptor 1 is that it will activate when there is a modification in the glycans in this TGF beta receptor 1 occurs, and the Sialyl levis A and levis 2 glycans are expressed. This will cause the activation of the TGF beta receptor 1. So when both of them combine together, at that time the intracellular signalings will occur. And before going into that, there is one more element. It is beta glycan. It is a core protein which is connected to this GAGs or glycosaminoglycans, and it also has a role towards this TGF beta signalings, but that role is not clearly understood. So what composed of this lipid raft? First we will understand what is this lipid raft. Lipid raft is the dynamic change in the structures of different components of the cell surface, thereby helps in the signal transduction. In this case, signal transductions of TGF beta. So what this lipid raft is composed of? It has, of course, this TGF beta receptor 1 and TGF beta receptor 2. Along with that, they will also have this glycosphigolipid and cholesterol, and together they form a microdomain, and this microdomain enhance in the signal transductions of this TGF beta. And here we can see that the TGF beta receptor 1, it will has the Sialyl levis structures that is shown in the TGF beta receptor 1. And in the case of this glycosphigolipid, in that case the glycan structures are directly attached to the cell membrane, and similarly for the case of this cholesterol. And so cholesterol are mentioned here. So these are the glycophospholipid. So lipids, these carbohydrates are directly attached to the cell surface. So this lipid raft, it's not necessary that they needs to be in this order. The important thing in this macrodomain is that this TGF beta receptor 2 and TGF beta receptor 1 needs to be close to each other, so that once the TGF beta interact, it will cause the phosphorylations of the intracellular domain that will trigger the EMT, it is epithelial to mesochemical transition. And one common things about this TGF beta receptor 2 and TGF beta receptor 1 is that both of them are heavily glycosylated, containing both N-glycans and O-glycans. And however, the O-glycans are not shown in this TGF beta receptor 2, but it is mentioned in their text that both of them are heavily glycosylated with N-glycans and O-glycans together. And other things that I have just mentioned at the beginning of the video, that the core-fucosylations. So if this fucosylations is inhibited or is not working properly within the cells, then it will prevent this TGF-beta receptors to be expressed from the cells, and it will reduce the TGF-beta impact. So these core-fucosylations of those receptors are really critical part for the TGF-beta signal transductions. So that's all for this video. If you need to understand more about this glycosylation in TGF-beta receptors in detail, you can go through the reference that has been provided in the description. That's all for this video. Thank you for your time.